This is the story of a particle, small yet powerful, a breakthrough in the way we control heat. Heat is energy, a force all around us, shaping everything it touches, moving freely, uncontrolled and uncontained. It shapes our cities, pushes infrastructure to the limit, and drives up energy costs. In industrial settings, uncontrolled heat puts workers at risk. Uncontrolled heat in the form of wildfires are growing more destructive each year, destroying millions of acres and threatening our communities. We've tried to fight it, but traditional solutions are costly, bulky, and limited. But what if we could control heat at its most fundamental level? Meet the Insulative Ceramic Particle, or ICP, by NanoTech Materials, the microscopic breakthrough in heat management. Unlike traditional materials that struggle to contain heat, ICP seamlessly integrates into coatings materials, providing extreme thermal protection without compromising strength or integrity. Blocking, redirecting, and releasing heat with precision. Lightweight, seamless, no toxic chemicals, no bulky layers, just pure integrated innovation. In industrial settings, a single millimeter of ICP enhanced insulator reduces surface temperatures by up to 40%, protecting workers and conserving energy. Our wildfire shield coating protects critical wooden infrastructure, like bridges and highways, from wildfires up to 1,800 degrees Celsius. ICP enhanced cool roof coat transforms buildings, reducing cooling costs, lowering emissions, and making cities more resilient. And this is just the beginning. New innovations emerge every day. Clear coatings for windows, fireproof packaging for safer battery transport. Every ICP application isn't just a solution, it's a step toward a more sustainable future. This is the story of a particle, redefining what's possible in thermal management. NanoTech Materials, formulating the future. This is the story of a particle, small yet powerful, a breakthrough in the way we control heat. Heat is energy, a force all around us, shaping everything it touches, moving freely, uncontrolled and uncontained. It shapes our cities, pushes infrastructure to the limit, and drives up energy costs. In industrial settings, uncontrolled heat puts workers at risk. Uncontrolled heat in the form of wildfires are growing more destructive each year, destroying millions of acres and threatening our communities. We've tried to fight it, but traditional solutions are costly, bulky, and limited. But what if we could control heat at its most fundamental level? Meet the Insulative Ceramic Particle, or ICP, by NanoTech Materials, the microscopic breakthrough in heat management. Unlike traditional materials that struggle to contain heat, ICP seamlessly integrates into coatings materials, providing extreme thermal protection without compromising strength or integrity. Blocking, redirecting, and releasing heat with precision. Lightweight, seamless, no toxic chemicals, no bulky layers, just pure integrated innovation. In industrial settings, a single millimeter of ICP enhanced insulator reduces surface temperatures by up to 40%, protecting workers and conserving energy. Our wildfire shield coating protects critical wooden infrastructure, like bridges and highways, from wildfires up to 1,800 degrees Celsius. ICP enhanced cool roof coat transforms buildings, reducing cooling costs, lowering emissions, and making cities more resilient. And this is just the beginning. New innovations emerge every day. Clear coatings for windows, fireproof packaging for safer battery transport. Every ICP application isn't just a solution, it's a step toward a more sustainable future. This is the story of a particle, redefining what's possible in thermal management. NanoTech Materials, formulating the future.
Here's how cool roof coatings really work. For years, cool roof technology has focused on solar reflectance index, reflecting sunlight to keep surfaces cooler. That helps at first, but it has limits once the sun heats the roof. Most traditional coatings have high thermal conductivity, so heat conducts through the roof deck and into the building. Over time, dirt buildup, material aging, and heat soak reduce that performance even further. NanoTech Cool Roof Coat is built differently. Its defining property is low thermal conductivity, engineered to resist heat flow, not just reflect it. Inside the coating are NanoTech's insulative ceramic particles, millions of microscopic speed bumps that interfere with how heat moves. As heat tries to move downward, that low conductivity disrupts and delays the transfer, giving heat time to radiate back toward the sky and be carried away by natural airflow. So what does that mean? In practice, it means lower roof surface temperatures, less heat reaching insulation and decking, and reduced cooling energy cost. Instead of pushing heat into the building during peak sun hours, the roof stays cooler throughout the day and releases stored heat as outside temperatures drop. The result is real-world performance: 30 to 50% cooling energy reduction, more stable interior temperatures, longer roof service life, and performance that does not fade as the roof ages. Traditional cool roofs focus on cooling the surface. NanoTech Cool Roof Coat controls it with low thermal conductivity. That's the difference between looking cool and keeping the building cool.
Hey, good morning or good afternoon, everyone, or potentially even good evening, as I know we have some international folks joining us today. My name is Allison Anderson. I am the Senior Vice President of our NanoTech Materials Division. And I want to welcome you today. We're going to cover our cool roof coat and the science behind it and how it is different. We'll go ahead and get kicked off, but just a couple of housekeeping items. This is a recorded session, and everybody who registered will receive a recording or a link to it after the fact. So if you have to jump off early for any reason, no worries there. You'll also see that we have some materials in our leave behinds here. We'll send out some materials after the fact, and we'll be available for questions at the end of this session. So let's go through the agenda here. So here's our roadmap for the session. We're going to start with the true cost of an inefficient roof. We want to make sure everybody understands that. Then we will go through SRI. SRI is the current industry standard way cool roofs are measured today, and we'll talk about where the gaps are with that standard. Thirdly, the breakthrough, which is our ICP or insulative ceramic particle. We add a thermal property called low thermal conductivity that most cool roof products completely ignore. And then we'll close on how cool roof coat pulls it all together in documented savings. And like I just mentioned, I'll leave time for questions at the end. So jot them down as they come up or use the chat box and we'll handle those at the end. So before we talk about any product, it's worth understanding just how much an ordinary aging roof is costing you. So we're going to start there. I want to frame what an underperforming roof is actually costing you or the facility owner, because the roof impacts different budget lines and most owners ever really see one of them. Let's talk about a dark roof. A dark roof isn't neutral, it's a solar collector. It can absorb about 90% of the energy landing on it and runs 150 to 190 at midday in the full sun. That heat has exactly one place to go if it's not emitted away, which is down into the building. Recently, my own project manager was up in Ohio on an EPDM roof, and usually when we think of hot roofs, we think of the South, but Ohio's Midwest or Great Lakes, depending on how you want to identify it. But when he was up there on about a 95-degree day, that roof was reading 212 degrees Fahrenheit. So if you can imagine, that really can impact what's underneath. According to the EPA, direct and indirect greenhouse gas emissions from homes and businesses account for 31% of the total U.S. greenhouse gas emissions. Emissions can be reduced through energy efficiency. On average, in a commercial building, HVAC has the largest impact on the energy bill, which is roughly 44%. And all summer, it's fighting the roof. Every degree the membrane gains is the degree the compressor has to remove. So improvements that reduce HVAC energy use directly tied to emission reductions. Replacement is the number that ends up in our capital request most of the time. People are very familiar with replacement. We call it a full tear-off. And it ends up in capital, not operating or maintenance expenses. And heat is what pulls that date forward. Thermal cycling degrades seams and adhesives, so the hotter it gets, the more it contracts, goes back and forth, and can cause more damage to the roof over time. And you add any weathering or hail severity, it compounds on top of it. And if you're not completing preventative maintenance and actively repairing or maintaining your roof, it can definitely add up. According to a recent contractor survey, the average emergency leak repair call on a commercial building averages about $600. And that doesn't even consider all of the maintenance that goes on inside, from the cleanup and the frustration of the tenants, etc. An aging, non-reflecting roof isn't just a maintenance issue, it's a compounding cost center. So how does the roof actually drive that cost? If you think about it, on a sunny summer day, an uncoated roof surface can hit, like I mentioned, 150 degrees or more. That heat doesn't just sit up there. It transfers straight down through the roof assembly, if it's not emitted away, directly into the occupied space. And your HVAC has to fight every degree of it. According to Science Direct, up to 70% of a low-rise building's heat gain can enter directly through the roof. So the roof is one of the largest impacts on the heat gain from exterior elements. That's why roof surface temperature translates almost directly into cooling load. The hotter the roof, the harder and more expensively your air conditioning works. And remember, that's just an average of 44% of energy use we saw in commercial spaces. So if we keep the roof cooler, we're attacking the single largest energy component on the bill. Everything we just covered is an operating cost argument, but most of you also have a compliance calendar. So the question isn't only, does this pay back? It's, does this help me with what I'm already being measured on? So I'm going to talk about 4 places where it does, but there's many more of this, and there's local compliance issues too. Let's start with ASHRAE 90.1. This is the baseline energy standard for most commercial roof codes adopt. Cool roof requirements apply a low slope roofs over conditioned space in the hottest climate zones, with compliance typically requiring a 3-year aged solar reflectance of 0.55 and thermal emittance of 0.75. This isn't optional in a lot of markets, and if you're re-roofing, they'll be held to it anyway. I'm not sure if anyone from New York is on the line, but local law 97 is very relevant for commercial spaces there. Buildings over 25,000 square feet face annual penalties of $268 per metric ton of emissions over the cap. But the real hook is that the 2030 cliff is the 2030 cliff, because based on the 2024 energy performance data, about 9% of properties exceed their current 2024 cap, but roughly 57% already emit more than their 2030 cap. Most owners are compliant today, might not be compliant in 4 years, and they might not even know it yet. So anything that cuts the cooling load will reduce the tonnage that they'll be fined on. LEED. A reflective roof earns LEED points under the heat island credit, 1 or 2 depending on the project. And because it cuts cooling energy, it helps on the energy performance side too. The thing most people miss is that LEED doesn't score the roof on day 1. It scores how reflective it still is after 3 years. Cheap coatings fade and lose their number. Ours is built to hold it, and we'll talk a little bit more about that in the technology portion. Those who have facilities in California or are designing facilities in California know you have to meet Title 24. All new and replacement low slope roofs in California must meet a minimum SRI of 75. If you own a property in California, this isn't a preference, it's a condition on your next roof. We're not asking you to add a program, we're asking whether the thing you're already going to spend on your roof helps on the metrics you're already reporting on. that brings us to our second section, the science behind cool roofs today and the metric called SRI. So we'll start there so we have a good understanding and baseline of what SRI means. SRI stands for Solar Reflectance Index. It's an industry standard score for a cool roof, and it combines two things: how much sunlight the roof reflects and how well it releases heat it does absorb. A good SRI roof will typically deliver up to 7 to 15% cooling energy savings, so it can be helpful. But here's where SRI misses, and this is the crux of the whole talk. SRI is measured on a fresh, clean sample in the lab. In the real world, roofs get dirty and reflectance drops by roughly 18% per year as they soil and as the UV degrades them. 2, and this is the big one, SRI measures the surface, not how much heat actually transfers through the membrane into your building. 2 roofs can post the same SRI score and perform very differently once the heat starts moving through them. That gap is what our technology addresses. Which brings us to the breakthrough, adding a third dimension that cool roofs have never accounted for to date, which is thermal conductivity. This is what our particle looks like under a microscope, essentially. This is our ICP. The way that I always describe it when I've seen it is like a basketball with a bunch of ping pong balls on it. And even though we're going to talk about a finished product, which is our cool roof coating, our platform technology, this particle, is our patented technology. And this is what differentiates us from other coatings. The platform tech is our ICP, which is Insulative Ceramic Particle. Our ICP is an amorphous silica-based composite backbone cohesively bonded with our nanoparticles. And that sounds super complicated, but essentially we've combined safe, stable, and flexible materials that work together to give the particle advanced heat control capabilities, which we'll explore next. Because it's lightweight, chemically stable, and very small, we embed these particles into different carrier materials. Our first lines are all a coatings line. Our particle itself is about 10 microns, and the easiest way to say that if you're not familiar with microns is if you take a strand of your hair and you cut it by like 10 to 12 pieces from the tip, it's about that small. So we take that particle and embed it into different things. And I always forget to mention this, but we were actually recognized by Time Magazine as an invention of the year in 2024 in the materials space. So what we have really is groundbreaking, and it's been recognized as such. I know the video kind of lags when we're doing a webinar, but again, we'll be able to send this out, and all of our videos are on our YouTube page. But let me show you what we got here. So what does that particle actually do? We've developed a breakthrough particle which leverages 2 thermal properties. The first is an extremely high emissivity. Emissivity is a surface phenomenon related to the efficiency of emitting energy as thermal radiation, which can be visible in infrared wavelengths. You can see on the video here that we've coated a regular plastic water bottle in our particle. This is actually a demonstration of our wildfire shield. So it has more particle in our cool roof coating. But when it's glowing, you can kind of see that red glow in the middle, and that's an example of emissivity. For those familiar with emissivity, you know that most emissivity scores go from 0 to 1. Our particle obtained a perfect 1.0, which is really unheard of. In fact, we sent it off to the independent third-party lab, a reputable national lab, and they called us back and let us know they were sending the sample to a second lab because their equipment must be broken because it was throwing back a perfect emissivity score. They called back a week later after a secondary test to confirm it was reading accurately. The second property is extreme low thermal conductivity. The property is the ability to stop heat transfer through a substrate. We actually have a lower thermal conductivity than NASA uses on aerogels for its re-entry protocols. There are products in the market today with high emissivity, and there are products in the market today with low thermal conductivity, but the combination of 2 is truly unheard of. And what you're seeing here is our CEO, after blasting it with an oxy-torch for 5 minutes, he was able to touch the water. We kept it lukewarm. And that was really the combination of low thermal conductivity and high emissivity, as well as exceptional reflectivity. And although we're not talking wildfire shield today, you might have noticed that it wasn't smokeless, or that it was basically smokeless. There was no smoke there, which in the fire space is a really big deal because smoke is typically the concern for safety. If you throw in reflectivity, that combination of those 3 thermal properties, you have that formula for a really incredible cool roof. And I'm not going to bore you guys with what happens to an egg, but we've got a lot of these videos. We liked burning things at the beginning because it's so cool to actually see our technology in action, right? I'll fast forward it here a little bit. If you want to know what happens after burning an egg coated in wildfire shield, we're about to find out. Not a really big market for eggs and water bottles out there, but that's why we moved into retaining walls and infrastructure. Though for the remainder of the session, we are going to talk about the cool roof, but I wanted to share that we do have an entire line of products, both commercially available and in development. We can always discuss our other product lines offline, but we do have, like I mentioned, a fire mitigation line that's actively utilized in the California Department of Transportation to protect timber laggings on the retaining walls. We've gone on wood, we've gone on steel, as well as concrete. We can go on many things from a fire perspective, saving up to 3,300 degrees Fahrenheit. We have a cool roof coating. And then if you are in facilities or the energy space, something that we're not going to talk about today, but it's worth looking into, is our insulative coat called Cool Touch. Cool Touch can be used in a facility to protect up to 350 degrees from a PPE perspective. But we can also coat pipes, chillers, air handlers, things like that to stop corrosion under insulation and condensation. We can also help chilled water systems maintain cooling in a much more efficient manner. There's been areas in the new construction space where we've enhanced or even replaced traditional insulative jacketing. All right, let's bring it home. So we're going to talk about how all this translates into actual measured energy savings in real buildings. One thing I always like to point out is cool roof coatings aren't new. That's why we have the SRI. And again, we just kind of take it to the next level. But if you took our particle out of our cool roof coat, we still have a very great commercial grade coating. But you have the benefit of having both. So our product itself is an acrylic base. It has about 72% solids. That's a very high solids amount for a acrylic. But what that means is you get more product per pass when you're laying it down if you're a contractor. The performance, of course, it stops the heat penetrating through the roof, and we'll talk a little bit about some real measurable results from that. But it's incredibly durable and protective. It has an excellent adhesion and flexibility, as well as superior UV resistance. Our particle itself is UV resistant. It's inorganic like sand, so it doesn't break down in the UV. Although we haven't done too much work in the Miami-Dade County yet, hopefully we can move that direction. We did pass their test. And why that's important from a weathering perspective is Miami-Dade is the most weather stringent test any building material can go through. So when it comes to wind uplift, hail resistance, again, permeance, things like that, we've passed with flying colors. We do make it here in Texas. So I'm based in Katy, Texas, which is the Houston area. We manufacture here. Our materials are supply chain in the U.S., and our product itself has a 12-month shelf life. However, though we keep some inventory here in our Katy manufacturing facility, we actually like to make it fresh to order, and we have very large capacity in manufacturing. We have no detectable VOCs, and a standard 5-gallon bucket covers about 200 square feet. One thing to know is NanoTech must be installed by an approved applicator, and that can be one of your preferred vendors that we train and certify, or we have a list of preferred applicators. And one thing to note is, yes, this is a energy and innovative solution to reduce heat. So whether you're going for energy or whether you're going for heat mitigation due to working environment, safety, things like that, we do give a 20-year NDL warranty as a manufacturer. So that's a leak-free solution that will protect your asset and also stop leaks. So why coat instead of tear off? We talked about replacement being a typical capital expense that people go for. Well, a coating is typically 30 to 55% less costly than a tear off or an overlay. It also minimizes disruptions to an occupied building. No tenants are displaced, minimal noise, no demolition, so the business keeps running. So in the existing facility space, the existing building space, this is a really great solution. Code compliance is something too. The IBC, or International Building Code, limits you to 2 roof systems before a full tear-off is required. A coating renews the roof without triggering that. So That's a big deal for buildings that already have two. You can add a coating over the top of that if needed. From the sustainability standpoint, you keep the old roof out of landfill and cool roof energy performance on top to reduce the emissions to lower your energy costs. Then I mentioned on the last slide, but warranty is a really big deal too, because we are offering a 20-year leak-free in-deal warranty as a manufacturer. So you're getting most of the benefits of a new roof, but at a fraction of the cost and disruption. So what does that mean for an existing facility, and how does it really impact the energy saving? So I'm gonna put some numbers to this. If you recall, an average cool roof starts off at most 7 to 15% energy savings, but that degrades about 20% year over year. Let's talk about our product and what it looks like in the real world. What you're seeing here is a 180,000 square foot retail facility, kind of a standard retail store that you'd walk in, 30-foot ceilings, large open spaces. We coated an uncoated metal roof, of course, and at the baseline, the roof surface hit 149 degrees when it was only 90 degrees outside. So the ambient temperature was 90 degrees. But this is actually their data. And what they did was go inside the facility, took a thermal gun and read the temperatures right underneath the ceiling tiles, right under the mat insulation, and was reading 112 degrees. The problem is the HVAC was fighting the difference between the 70 degrees they like to keep it at and 112 degrees coming through the roof. After the cool roof was installed, the internal temperature, where it was reading 112 degrees before, got down to 73. What that meant for them is real savings. And they were able to reduce their cooling costs in that summer by 49%. But that's the whole point of our product, is we can extend the life of an asset for less than a tear off or overlay and reduce those energy bills. And although reducing energy and emissions is fantastic, and many Fortune 500s or companies have those goals, but this is money back in your pocket every single month. And you saved on the capital expense as well. Sometimes it's not about energy though. So it can be about safety and comfort. And I know OSHA has some heat mitigation laws that are now in place. And depending on the state, you might be required to keep the internal non-climate controlled space at 90 degrees. So we've done a case study here in Texas, which was an open air facility. So this building has no air conditioning. There's no thermostat to turn down, no systems to optimize. The roof really is the cooling system along with some fans. And that's why this one's such a clean test. We changed the roof and nothing else. The roof deck went from 162 to 105, which is a 57-degree reduction, and that was on about a 90-degree day as well. Inside, it went from 125 degrees to ambient, which, depending on the day, was anywhere between 90 and 95. The building stopped being hotter than outside, and that's really important. At baseline, workers were in the space 30 plus degrees hotter than the parking lot. After walking inside, it was like walking into an oven. Air temperature isn't what makes the warehouse miserable. 162-degree Fahrenheit ceiling radiates onto workers the way a broiler does. You feel it on your head, your shoulders, regardless of what the wall thermostat says. That's why heat stress standards use wet bulb globe temperature, which includes a radiant measurement, rather than plain air temp. Cutting the deck to 105 removes most of that radiant load. And this just improves working conditions for employees. One question I get, or one comment I get all the time is, okay, we get it, it's a white roof. Well, I'm showing you right here a white roof versus a white roof. On the left, we have a freshly cleaned TPO roof in Texas, in the San Antonio area. It was actually in September, so it wasn't even the hottest time of the year. It was reading an average of 118. And on the right, we have an average of 77 degrees. And that's after the coating. That's a 40-degree difference from a white roof to a white roof. And that doesn't even show the full impacts of how we're preventing the heat from entering through the roof. We're about to wrap it up here. So stepping back into the strategic view for decision makers, this is really 3 moves in one. First, you can remediate instead of replace, which is a cost-effective alternative to tear-offs. It can run you much higher to replace, and you're getting a Miami-Dade tested waterproof roof with a warranty. Though I'm not a CPA or an expert, you can always consult your CPA. A coating is considered a maintenance cost, which can be deducted in year one, versus a replacement or overlay, which is a depreciation schedule, typically over the course of 20 years. Second, you get unprecedented energy savings up to 49%, or you can make a more comfortable space in the building. And then third, it's a carbon reduction step. So the final case study here, or the final statement is cool roofs in general add value, but NanoTech Cool Roof really outperforms the competitors in the energy efficiency and longevity in the acrylic space. NanoTech Cool Roof offers both a practical and innovative solution for both facilities and sustainability folks. And again, they must be installed by an approved applicator. And that's pretty much it for us. Hopefully you take away some good points that our technology is our ICP, and adding that to a coating really takes a cool roof to the next level. I'm going to go ahead and stop here. We've got a few more minutes for some questions. We had a question about residential roofs. So currently we are not in the residential space. However, because the particle can be added to so many different materials, know that there will be expansion within each of our product lines. So make sure to follow us on social media and see where we're at. Do we have a list of contractors we can use? Really good question. A couple of things, and I kind of mentioned it, but we can utilize your preferred contractor as long as they have coatings experience. They are required to have experience, again, in coatings, a minimum of 5 years, and they have to go through our training. So you have two ways. We can either provide a list for you because we have a national list of over 100 contractors in the United States that can be utilized, or you can we can train one of your contractors. What are the next steps to become an authorized installer? Well, you contact us. That's the first thing you do. As I mentioned, we do go through to make sure that you have coatings experience. If you are a contractor or if you've done coatings, you know that the preparation and the installation, specifically the detail work, is incredibly important to a successful coatings install. And that's why we go through our due diligence and vet. So not every contractor is a candidate to become an approved applicator, but go ahead and contact us and we can start the vetting process. I believe that's it. So what's next? I do want to let you know that our webinars are going to be monthly. So we do have our particle guy. His name is Jonathan Butz, and he's our technical director here at NanoTech. He'll be hosting a webinar on August 26th, and that'll be our next one. And then in September, we'll focus on our insulative product, which again can combat corrosion under insulation. Make sure to go ahead and contact us. We can, if you're a building owner or an engineer, an energy engineer, consultant, we can walk you through our product lines, send over specifications. Do you know that all of our technical documentation is listed on our website at www.nanotechmaterials.com under our resources? So our TDS, SDS, and any information you might need for our roofing, insulator, or fire are all listed there. If you need an estimate, we can certainly put you in touch with one of our approved applicators. We even have, which I didn't talk about, but we have a physics engine which can model your building and estimate energy savings if it's an energy-driven project. Feel free to reach out to myself, and my information will be sent out via email after this session. Thank you all so much for joining today. I hope you have a great day.